I'm sorry. Section 3.3, we're going to talk more about holes and slant asymptotes today. So a hole is a point that is not in the domain, but it reduces from the function, so it's not a vertical asymptote either. Okay. Let's follow our steps that we learned in section 3.2 and start by factoring. Start by factoring. X plus 3 is already factored, but we're just putting in parentheses to make it clear that's a factor. It's like grouped together. We don't work with anything individually here. And then x squared minus 9 is a difference of squares. It factors into x plus 3, x minus 3. So then to find the domain, we would take each of our factors, x plus 3 equals 0, so x does not equal negative 3. And then x minus 3 equals 0, so x does not equal positive, right? So there's our domain right here. That's set notation. We could also write it in internal notation that shows what it can be instead of what it can't. Now we're going to reduce if possible. So we do have something that reduces this time right here, leaving us with the function 1 over x minus 3. Going to say y equals, because that's not our actual beginning function, h of x, because it reduced, but it is going to tell us what our graph looks like. Okay, now we're going to find our x and y intercepts. So for our x intercepts, we're going to take our numerator and set it equal to 0. So 1 equals 0. Can we solve that? We can't solve that, right? 1 doesn't equal 0. 1 doesn't equal 0. There's no variable in there. That doesn't even make sense. So what does that tell us about the x-intercept? We don't have one. No x-intercept. Okay, so then for our y-intercepts, we're just going to plug 0 in for everything. So 1 over 0 minus 3. Gives us negative 1/3. So in other words, our y-intercept is when x equals 0, because that's what we plugged in, y equals negative 1/3. I feel like my writing keeps getting bigger and bigger. Yeah, because here's our function. So we plugged in a 0 in place of the x. So 0 minus 3. Get our y intercept, right? So far, so good? Domain, reduced. We've got x-intercept, doesn't exist, y-intercept. Now we can do asymptotes. Show the whole page, keep going, and try not to write too big. Keep it out, let it get stuck on the page. That's annoying. Come on. Well then, it's just delayed. There we go. If I take the time, I can go into YouTube and delete that part of my video. Chances are I won't take the time to do it. So just try a little interruption. Okay, so vertical asymptote. Will be from this step right here. We just look at what makes the denominator 0, so x equals 3. And then horizontal asymptote, we look at our 3 rules we learned. And the 3 rules are, if the degree is smaller on the top, then it's y equals 0. If the degrees are the same, top and bottom, then it's the leading coefficient. And if the degree is bigger on the top, then it's a slant asymptote. We haven't learned about those yet. So in this case, it doesn't matter whether we look at our original function or our reduced function. The numerator is either degree 1 versus degree 2, or in the reduced one, degree 0 versus degree 1. The numerator is smaller degree than the denominator. Correct? So that's rule number 1. rule number 1 means we have a horizontal asymptote, sorry, at y equals 0. Okay, so let's put in what we know. So we've got vertical asymptote at 3, horizontal asymptote at 0, with no x-intercepts, have a y-intercept at -1/3, so about right there. We also have the facts that we learned in chapter 1 about transformations. And therefore we know that this is a reciprocal function that's been transformed to the right of 3. So without plugging in any further points, we should know what this looks like because we should have that toolkit reciprocal function memorized. Okay? But just in case we don't, we could plug in some other points. So choose some points to plug in. I recommend making sure you've got points between asymptotes and intercepts. So you might want to plug in something left of 0, something between 0 and 3, something that's bigger than 3 especially. So like plug in a 4, and I can just plug that into this part of the problem right here. Or I can go back to the original, it doesn't matter, it's not the same. So 4 plugged in here would be 1 over 4 minus 3. Well, 4 minus 3 is 1. So that would be 1 divided by 1, which is 1. So that gives us a point at 4, 1, which agrees with the fact that we have a reciprocal function that's just moved to the right 3. So as long as we're comfortable with where those pieces of our graph are, we can sketch those in. We can plug in more points if we feel like it's necessary. Now we need to be aware of the hole in the graph. So if we plug in a -3, if we plug that into the original problem, it's going to be undefined, dividing by 0. So it doesn't exist there. So what we're going to do instead is we're going to plug it into this part right here. So then we'll have 1 over -3 minus 3. So that would be 1 over -6. So -1/6. That is the hole in the graph because it's not in the domain. It's not in the domain. If we plugged it into the original function, we would have had an undefined problem dividing by 0 we can't do. But because we plugged it into our reduced problem, we were actually able to figure out where that point is. And so now we just mark it in our graph with an open circle. And our open circle is located at -3, -1/6. And we found that point by plugging it into the reduced function. Again, it wouldn't have worked before. Plug it into the reduced to figure out where that point is, the x and the y. Okay? We cover all the steps